the work group covered a number of issues, as you all know, so there's plenty of work to do. One of the things that was of interest to people in particular was soil capital or soil health. And so Dee Dee and Kat, two of our participants in the work group, offered to share some of their learning and thinking about that today. So we've arranged for that, and we're going to have Kat go first, and probably 20, 25 minutes. We'll leave a little bit of time for questions via the chat function, or the Q&A function, I'm sorry. And then we'll go to Dee Dee and the same. And then we'll make sure this is posted on the website so it's available as well. We also want to hear more about the Cornell Soil Health Index, and we're trying to work with Heather Darby to figure out a time when we can do that, so that will come at a later point. Right.
So yeah, I'm Kat Buxton, and I am a soil health, compost, garden, public educator here on the working group as a part of the Vermont Healthy Soils Coalition. So I'm going to give a little presentation about soil health as I understand it and how I like to talk to the world about it. And I always like to start off with framing the whole picture. So one of the most alarms that I've heard from a UN senior official was that the world has 60 years of topsoil left if we continue with the agricultural practices globally that are dominant right now. And that's really scary to think about. There are some statistics here on the screen. I don't like to read my slides, so I'm going to let you read those. But I will just reiterate one piece here that, you know, corn and soy are clearly some of the largest crops by acreage or hectares globally. And for every pound of corn that is harvested, we lose over a pound of soil. For every pound of soy that is harvested, we lose 2 to 3 pounds of soil. This photo that we're looking at is taken in Iowa in 2018 by one of my colleagues, Peter Donovan, where they are clearly, it's like they forgot about the Dust Bowl and they're farming right up to the river again. You can almost see, even in this still picture, the soil falling into that river and heading out to the oceans. So the NRCS, Natural Resources Conservation Service, has come up with some soil health principles. The top 4 that you see on the screen are the ones that are promoted by the NRCS, and they're all great. So I'm going to go over these soil health principles with you. Number 5 is one that was coined by a now famous rancher in North Dakota, Gabe Brown, who's also written a wonderful book. If you haven't checked it out, it's From Dirt to Soil. It's wonderful, and I recommend the version where he narrates it. It's great. And then the 6th one, slow and sink the water, really just makes sense and comes from the work that I've done with Michael Krauschik, who is a hydrologist. I've learned a lot from him. So the first principle, living roots in the ground for as long as possible with greening plants on. We have living around, we are conducting synthesis, use leaves on top, which is feeding biology underneath the ground. I love this slide. There are many of the drawn pictures here of the plants that actually we have in Vermont as well, so it's not totally irrelevant, but these are root systems of prairie plants. And I always like to point out that some of those roots in this picture are going down to 15 feet. So the potential for root depth is there if soil health is it. It all comes back to photosynthesis, and the sun has an energy budget. We are going to focus on the 40 to 60% that plants invest into their root system. They actually invest it into the microbes in the soil that are cycling the nutrients back into the plant. So very basic stuff here, sunlight, sugars. So photosynthesis is taking oxygen, carbon dioxide out of the air, turning it in magically, I like to say, or scientifically, depending on how you like to think about it, into sugars, long chain carbons. So this is how we draw carbon down from the atmosphere using the most advanced machines ever, leaves, to feed carbon into the soil. And carbon is, of course, the living, the dead, and the very dead. And I like to focus on the little microbes that are doing all the work for us biological workers. When those sugars or those exudates, Elaine Ingham, one of my teachers, soil microbiologist, likes to call those the cakes and cookies, those sugars. Sunshine fed through the root system into the rhizosphere. So every single root hair in the soil has this microscopic zone called the rhizosphere. And in this slide, that is indicated by the blue area around this root hair. And on the left side, you're looking at the tree, looking at what is potentially the rhizosphere. I say potentially because the more we learn about soil microbiology and the work of these biological workers in the soil, that we're learning that that rhizosphere is actually quite vast. And once you include the mycorrhizal fungus that can communicate among different species of plants, sort of working laterally in every direction, but laterally through root systems, that rhizosphere increases dramatically. The little red dots that you see in that blue section around the root hair are indicating biology. So those would be the bacteria, nematodes, protozoa, microarthropods, all around the root hair. Those are the ones that are solubilizing sand, silt, and clay, producing organic acids to take those nutrients and make them available in a soluble form near the roots where plants can take them up. The little white hairs coming in from the side are actually fungal hyphae. The more we learn about fungal, specifically mycorrhizal fungus, the more we are beginning to understand the incredible selective intelligence and communication network among plants under the ground using biology as their conduit. And so the soil food web was coined as a term in the mid-90s, and our understanding of how the soil food web works is really just beginning. The soil microbiologists that I have worked with have told me that we think we know about 5% of what there is to know about the soil food web. And the more we learn, the more it's flipping what we thought we knew upside down. So I think it's really important to continue to focus on these biological organisms that are in fact the ones that create the matrix, the cathedrals, as Walter Jehne likes to talk about, of soil aggregates, soil stability. And again, looking at this slide, now that we've talked about a rhizosphere, I see this picture as showing incredible potential, knowing that if we have room in the soil and we have deepened our soil, our topsoil, so that plants can get through, so that it's not compacted from plow pan and other things, the rhizosphere is vast, and the potential for organisms in that rhizosphere is incredible. So again, we know now that roots can go quite deep. They can go a lot deeper than 15 feet, depending on where they are and what kind of plant they are. When I talk to folks about this, I always like to point out that little red circle on the top left is your standard lawn grass. There are 43 million acres of lawn grass. So I know we're here talking about farms, and that's an important part, but I also just want to point out that there are lots of other landscapes where we could be employing these soil health principles and increasing the potential for the biological capital that the soil provides for us. The second principle is maximizing diversity. That's diversity above the ground, below the ground. Shoot, it's even within human systems and the way we think. Diversity of animals above the ground, diversity of plants above and below the ground, animals above and below the ground as well. I love this slide because it's just a square foot, but it shows the kind of potential. I'm really into potential. If we can diversify and create the conditions for ecosystem biodiversity, a lot of our ecosystem services are cared for. It's actually not something that humans do. We can create the conditions for biological activity to happen. And that biological activity is promoting the ecosystem services. So on the left-hand side of this screen, you will see all of the things that are pretty hard to see around what look like flower petals in those three panels in the center of the screen. So on the left panel, natural ecosystems are providing for us all of the ecosystem services that all creatures on the planet need in order to survive. Well, that wasn't enough for humans because we wanted crop production. And so go humans, we went in and at the expense of all other ecosystem services, we enhanced crop production, which is arguably producing foods that are really no longer nutrient dense especially those super processed foods. So if we were to rethink whole systems and rethink our place in ecosystems as a part of ecosystems, could we move toward that panel on the right where we are both producing crop production and ecosystem services at the same time? Can we shift our systems to provide multiple ecosystem services versus single services? I feel very grateful to be in a place in the country where we, in fact, promoting farming that you're seeing on the left side of the screen. In fact, those pictures are all taken from either Vermont or New Hampshire. And in those services, in those photos, you can see a lot of other ecosystem services being provided, especially in comparison to the photos on the right-hand side, which is unfortunately how most of the food in our grocery stores is produced, at the expense of all other ecosystem services, and in fact, creating problems where there could have been clean water, we have dirty water, etc. CO2 in the air is definitely a problem, and we know this, and we focus on fossil fuels as a part of what we need to get a handle on, and that's certainly true. We do need to do that. But when we think about all of the man-made deserts that have been created across the globe due to our farming practices, we know that 50 to 70% of the world's original soil carbon, which was just in biomass and in biology under the ground, has been lost to land cultivation, because when we rip open the land and leave it bare, all of that life respirates into CO2. Our current agricultural practices are causing all sorts of problems, carbon in the air being one of them. Certainly agriculture is one of the largest contributors to carbon dioxide overload in the greenhouse gas layer, but also methane and nitrous oxide are also large contributors to greenhouse gas and are more potent as heat trapping gases than carbon dioxide. Our excessive use of nitrogen fertilizer is definitely causing hypoxia, ocean dead zones, along with other chemical pollutants that we're putting into our waterways, not just from agriculture, but agriculture is certainly a large player there. And as I understand it, a good percentage of the nitrogen fertilizer and other fertilizers that we put into our landscape to grow food actually just end up in waterways. They don't even get taken up by the plant. Here we're looking at two slides. One is drawn and one is a real life photo, and they're essentially the same thing. This photo on the bottom, Dee Dee's going to talk about this slide a little more in depth, but I'll just tell you that both sides of the fence used to look like the right-hand side where it's all bare. And it looked that way for decades. This is sheep country in Karoo, South Africa. The only thing that changed is on the left side of the fence where you now see grasses. They changed the way that they move the livestock. So they started using fences to replace predators. This is holistic grazing management based on some of the work of Alan Savory. And what we see here is that carbon and water on the left side are sinking in and cycling naturally the way ecosystems would like to provide that service. And on the right-hand side, when water falls, it evaporates right back up to the sky because it can't infiltrate into that dead soil. The carbon also respirates if there's any. It's respirating out because it's bare. There are no living roots or not enough living roots to really support the biological systems under the ground that would be cycling nutrients, water, and carbon. So that's the fourth principle, no bare soil. I point out when I say no bare soil, I'd rather say minimized bare soil. There certainly are insects and other biological creatures that rely on bare soil and on disturbance, but humans have a way of overdoing everything, including providing too much bare soil and way too much disturbance. So really it does all come back to photosynthesis. Can we grow more plants to maximize the sunshine that is feeding the biological network of creatures underneath the ground that are providing the basis for our ecosystem services, which is the ability for carbon and water to move freely through landscapes. This picture on the bottom right, you can get a really up-close view of this if you go to the soilcarboncoalition.org. website and search for NDVI, which stands for Normalized Difference Vegetation Index. This photo is essentially a still of 3 years of photosynthesis, photos taken every 16 days measuring the amount of photosynthesis activity in a landscape. This is Lake Champlain. So again, this is like a 3-year compilation, and the darkest areas on the map are showing where photosynthesis is happening a lot, and the brown areas where it's really not happening. And one really interesting thing about this map, there's a lot of interesting things about it, but if you were to zoom in with a high resolution on your computer through the Soil Carbon Coalition website, you would actually see that there are places in the lake that are producing more photosynthesis throughout the year than places on the land. And that's because of the cyanobacteria and algae blooms in the lake that are caused largely from phosphorus overload. Here's a little bit closer version of that. And again, the map in the darkness of green is showing the intensity of the photosynthesis. So again, when I look at this map, and as I'm always looking for possibility, I see possibility here. We know how to grow plants. If what we know we need to do is increase the amount of photosynthesis that's happening all the time, everywhere, we can grow more plants. We can be smarter about the plants that we grow. We can use cover crops, which is happening a lot more in Vermont, and that's fabulous. That's a really good start. So I highly recommend checking out these maps. There are quite a few of them now that are up on the Soil Carbon Coalition website from all around the country. But this one of Lake Champlain, I think, is really telling. And just look at north of the lake. This is not in Vermont, that's Canada. But what would happen if partners to the north were to increase photosynthesis? Would that affect the health of our lake? Closer in, you can see in Addison County, where we have a lot of farmland, that we have a great potential there to increase photosynthesis as well. The fifth principle, animals in contact with soil. This is the one that was coined by Gabe Brown, the North Dakota rancher. And it's based on the principles of holistic grazing management and rotational grazing. And it's basically grouping your livestock together in a greater stock density than you would have before, and using fences to replace what predators used to do, keeping herds close together, lots of trampling, lots of movement, and you're moving them often, sometimes every hour, sometimes every few days, depending on a lot of different components, like what kind of land you have, what kind of crops you're growing, what the weather's like, what time of year it is, etc. And in doing this, we're able to see massive land regeneration, just like that fence line picture that I showed you just a moment ago. The left side of the fence, the only difference was the way that they moved the animals. And within a couple of years, they had a very different landscape where a raindrop was going to act very differently. Much like this is another one from Kenya, again from the Savory Archives, and again, sheep country. So on the top left, we're looking at a photo that is bare ground for decades. This is what this landscape looked like for a long time. This is the same landscape appearing 4 times, and you can look at that central tree for orientation to the landscape. The only thing that changed on this landscape was the way that they moved their sheep around. They used to just let the sheep out, and they would eat whatever they wanted, and then at some point they'd come back and gather them up. They started doing holistic grazing management, grouping the sheep together, moving them around, and within 1 year, there was an appearance of annuals. Within 2 years, it was densely packed cover. So you can see the difference of what would a raindrop do in the top left when it hit, and what would a rain do right below that in 2006. Already quite a big difference. And just in case you don't know, the raindrop on top would splash, compact the soil, and then evaporate. And the one in densely packed cover would slowly infiltrate into the ground and remain potentially through even a drought season, so that those plants could continue to get water. Just 7 years later, that same landscape with the same holistic grazing management is now hosting deep-rooted perennials in addition to annuals, and the ground is covered all the time. So here we see, just with one change in practice, health principles are allowed to function. The conditions were created for biology to do the work to bring back the ecosystem services. Back in Vermont, we are looking here at what water does when it moves through landscapes at alarming rates. This is after Hurricane or Tropical Storm Irene, where many of us know farms and farmers that lost everything or near everything, certainly their whole crop that year. And many had deposited now sometimes toxic soil on top of their farms that came from our rivers that were moving way too fast because we feel like we need to channelize every river and have really big drain pipes. So when we channelize water, it moves fast, and guess what? Fast moving water is really damaging and will wipe out entire cities. If we could get that water to soak into the soil carbon sponge using the soil health principles, we might be able to mitigate the amount of water that's moving so quickly over our landscapes. On the bottom right, that is a picture of Thetford Elementary School where I run the school gardens. And that is about 8 foot of standing water over top of a drain. That happened on July 1st, 2017, which was just a rainstorm. We got 7 inches of rain in a day. It wasn't forecast to be anything but a rainy day. And as an end result, we actually received billions of dollars worth of road damage all over the state. This is a pretty famous picture at this point. This is, am I getting a chat message? Okay. This is Long Island Sound after Tropical Storm Irene, and you can see Vermont dirt roads and our farm soil depositing into Long Island Sound. And that's what happens when we don't have the goos, glues, snots, and slimes that the biological creatures make for us. So can we measure impacts and outcomes? We are measuring impacts. We are measuring massive amounts of road damage, infrastructure damage, drought, flooding, erosion, sedimentation, atmospheric carbon, nutrient runoff, nutrient leaching. We're measuring those because they're costing us a lot of money. They're costing us our farms. They're costing us our ecosystem services and our public health. But on the right-hand side of this slide, these are things that I would like to see us start measuring. How can we measure and value these so that we're actually promoting systems that sustain life on this planet? And this is my last slide. I don't want to read it to you, but there's some really good information on there. I will point out that that last blocks in purple, the 1% increase of organic matter in the top 6 inches of soil can store over 20,000 gallons of water. When I talk to homeowners, I say, hey, for every acre of land that you own, if you can just increase your soil organic matter, you could have a swimming pool's worth of water in the sponge in your yard so that you don't dry out when we go into our long dry spells. But one important thing, of course, to point out there is the soil clay or is it sand underneath? And there's going to be a lot of variability depending on that. So that is it for me. I would love to take any questions if you have any. Dee Dee's going to reiterate some of these points in her presentation, and so we'll also have time after hers.
Great, Kat, thank you. So if folks want to ask a question, there's 2 ways. You could raise your hand and then we can unmute you because we just have a few number of folks on the phone. Or if you want to send a Q&A in, you can just write it in and then we can share it. So if anybody has questions for Kat, now's the time to either just raise your hand and or sort of type them quickly into the question format. Kat, while people are doing that, a question for you is, as you think about those 6 principles and you think about the translation into potentially some form of a payment for ecosystem services, do you have thoughts about what a bit of that crosswalk would look like to move from these good principles to some kind of, PES system?
Well, I'm excited to be a part of this working group to work that out with all of you guys, because together we're a lot smarter to try and figure out how to do that. One of the things I see is how do we invest in the prevention of damage? So what can we do to invest in the prevention of damage? And in almost all cases, water infiltration really seems to be an important part of that. If we know that water can move into the landscape and back toward the aquifers, then we know that we're improving soil health, and we know that we're preventing potential infrastructure damage. So I'm certainly open to learning about other ways that we can measure those things, but I think water infiltration is a really big part of that.
That's great. And you make a nice case for us. One of the ways potentially to find the economic value is the avoided costs that you name for the things we don't want.
Yeah.
Great.
Kat, I was wondering if you might go back to the photosynthesis slides, Peter's NDVI slides for a moment. There's a couple of things that I think are worth pointing out in there that would be fun.
Okay. How about that one?
Let's see, it's your slides are going, yeah, there we go. And so in this one, I just want to point out that the white in the lake, and then is actually photosynthesis. That's not absence of water photosynthesis. And if you look up near the top, near just above the Canadian border, you can see there's a lot of photosynthesis happening up right to the left of the word is there. And then I think your next slide was the one that was kind of zoomed into Addison County, or.
Yeah, let's see. I'll do that. There we go.
There's a little delay in the slides showing up.
There we go.
Yeah, so in the Addison County one, you can see there's tons of photosynthesis happening along the lakeside, at 25, 25 and also 45, you start to see some brown and even some green happening in there. Some of the green may be more like little islets and islands, but that white along the edge is definitely reflecting the lack of photosynthesis that's happening inland. So the more brown there is, the more white and brown there is in the lake.
That's a nice point. We want more more photosynthesis on land and less
in the water. Yeah.
Great. Well,
Thanks, Dee. That's great.
Kat, thank you so much. We really appreciate it, and really helpful and informative. And we're going to turn this over to Dee Dee then to kind of take us for the next little bit.
Okay, great. All right. So I'm Dee Dee Purshouse, and Kat and I are kind of sharing a seat on the working group with the Vermont Healthy Soils Coalition. We both also work with the Soil Carbon Coalition. We're both board members there. And my current biggest project is something called the Land and Leadership Initiative, which is providing educational resources and strategic support for leaders of any sort who are working to make landscapes work better for everyone in their region. And I'm gonna focus today on one aspect of what Kat was talking about, which is the concept of the soil sponge, and thinking about this as a new narrative. We've heard a lot about soil carbon recently. Soil carbon, in my experience, having traveled a lot around the country, can be useful up to a point, but there's a certain place where it starts to become a little bit divisive between liberals and conservatives when it's only framed as drawdown of atmospheric carbon, and it's also, soil carbon is a little bit abstract for a lot of people, just as atmospheric carbon is a little abstract. So the soil sponge is more of a both structural and functional term that we've found really useful to get people to think about the interrelationship between soil and water. Let's see here, I'm gonna move down, here we go. A lot of what I'm gonna be showing today comes from a facilitator's manual that I wrote called Understanding Soil Health and Watershed Function, which is available as a free download at soilcarboncoalition.org. And one of the exercises we'll often do is to start off by having people look at this slide that Kat showed and just imagine yourself in this landscape on a hot day, maybe a 90-degree day. And there's a bunch of different sensory things that we know about healthy soil versus degraded soil just from our own experience. So if you take your shoes off and you stand over on the right side, and let's say there's a little door in the fence there, I think most of us would very quickly want to run back over to the left side just from our own experience, that we know that land on the right is re-radiating, absorbing a lot of heat and re-radiating even more heat due to something called the Stefan-Boltzmann Effect. And that has to do with the lack of water in the soil and the lack of transpiration happening on the land. I talk about these things with pictures a lot because I think, and also activities outside that we do, because we can get into physics and physical terms, but we do know these things with our own bodies. We know what a healthy landscape feels like. You can think about the sound. If you were to be in a landscape that all looked like the right versus the left, you know that there's a lot more life in the land, even if you can't see it, just from hearing the insects, the birds, animals, etc. If you were to imagine trying to stick a stick in the ground in one side or the other, on the right side, it would be very hard to push in, and on the left, it would be much more likely to be spongy and sink in because you have a lot more air space, pore space, sponginess of that soil. And what we're going to spend a lot of time on today is more about what happens when water falls on one side or the other. Take a moment to just think about what are some of the things that we are worried about with climate change. Let's see, actually, I'm gonna skip ahead here, but when we think about climate change, we are often thinking about flooding, about drought, about food availability, about ocean rise. What else? Feel free to unmute and jump in. What are we thinking about? Water quality goes down as water becomes less available. Heat issues, and if we go back to this slide, we can think about the temperature on one side or the other. Loss of biodiversity.
Forced migration, conflicts over lack of resources. And we can start to think how those things might play out. You could say that the right side is a landscape that is affected by climate change and the left is not. And yet here we are, and they're both happening at the same time. So where does climate change come from? And can we protect ourselves? Can we build a landscape that's resilient against all of these things? And I say, yes, we can. And there's a quick little exercise I do often at the beginning of my talks to show how healthy soil versus unhealthy soil reacts, particularly in terms of flows of water. And if you think of a pile of flour as degraded soil or soil that has no biology working in it, and you poke some holes in a cup and rain on that landscape, you'll see that just like that landscape on the right side of that fence, the rain is going to run off, it's going to erode the soil, it's going to take those soil particles into the water, to the rivers, streams, lakes, etc., and eventually into the ocean. And very quickly, with a small amount of rain, we've got a flood happening here. And underneath that water, there is, the plant roots are not actually getting it. Anyone who's done any baking knows that if you rain on flour, you're not getting any water down into the what we're pretending is soil here. Whereas if you add biology to flour in the form of yeast, you suddenly end up with bread. And now we're talking about, this is a metaphor for healthy soil. Suddenly you have pore spaces that allows that rain to soak in, and you have structural integrity. That means that if a big wind were to come along or a big flood, that the soil here holds together, the landscape holds together. So I like to ask people, if you were in a place where it rained a lot, like Vermont, you want to have a landscape that's like this bread made out of a healthy soil sponge. And also, if you were in a place that didn't rain much at all, you still want this, because as Kat pointed out, that having that sponge means that your land can hold that water for later use. It's protected against evaporation. The soil sponge also has that structural integrity, so that when water moves through it or wind moves across the land, that soil's not going to blow away. So this is building up this biological capital that provides all kinds of protection for us. Another way to look at this, this is a photo from the soil health team of the NRCS.
to show that structural integrity, that those soil particles, those little broken down rocks, sand, silt, and clay, can hold together because of those biological slimes and glues with a healthy soil like you see on the right. And with an unhealthy soil, it's more like flour. If you immerse it in water, it immediately falls apart. So the right side, if you have this set up on a table and you have a truly healthy soil sponge, that will stay intact for 24 hours or more, sitting in water. Probably the best example of it, though, is with a rainfall simulator. And these, really important to know that each of these soil samples, it's like a big cookie cutter pushed down into the ground. So it's open on the bottom and open on the top with a small screen underneath to make sure it doesn't just fall out. And these are all the same soil type. So same ratio of sand, silt, and clay. So in theory, the water should infiltrate at the same rate with each of these because it's all the same soil type. But each of these trays is taken from an area of a farm that is doing different kinds of management. So on the far right, none of the soil health principles are being used. And on the far left, all of the soil health principles are being used. And it's kind of a gradual transition from right to left. The jars that are underneath are collecting infiltration. The jars that are in the front are collecting runoff and eroded soil. So if you'll notice on the far right, there is no infiltration happening. We've taken a kind of a shower head and rained about 4 inches of water on this 3 to 4 inches of soil. And you'll see that none of that water got in. It all ran off, and it actually took a lot of the soil with it. So that structural integrity issue is really problematic here. As you move to the left, you'll see that water starts infiltrating more and more until on the far left, with the diversity, the long-term living roots in the ground, no disturbance, no biocides, et cetera, and animals in contact with the ground, there suddenly you have water that is clean and clear, that all the water has infiltrated and none of it has run off. So this is a really, when the NRCS does this demonstration at farm shows, et cetera, at the end, they'll often take that pan on the far right that's been heavily tilled, that's has had no cover crop, monocropping, et cetera, and they will flip it over and a big cloud of dust will come up from the bottom. And they call that the oh shit moment, because farmers watching who have been told for generations, or not that many generations, but for decades, let's say, that to open up the land, you need to open up the land for the rain to get in. So you need to break up the soil by tillage in order to make sure that the rain will soak in and that the soil will be nice and soft. But in fact, the opposite is true. So we see that the land that has been not tilled at all, is accepting a lot more rain than the tilled soil here. Okay, and just this is not really a new problem, that the deserts of the world, most of the deserts of the world are man-made deserts, including the Sahara. Plato, 2,400 years ago, talked about this issue. The land reaped the benefit of the annual rainfall, having an abundant supply in all places, not as now, losing the water which flows off the bare earth into the sea. So I like to talk about this soil sponge as a living system. It's got a digestive system, a respiration system, a reproductive system, et cetera, et cetera. Very importantly, it has a circulatory system for both nutrients and fluids and oxygen, et cetera. We can also think of it as the mucous membrane of the earth. It's a microbially rich space where life's processes take place. It's a functioning whole, like our own bodies, which can be injured if not treated right. And therefore, we need to think about principles for keeping it healthy. And I like to distinguish between principles and best management practices, that when we provide land managers, or when land managers are operating based on soil health principles, this allows for constant creativity, constant learning, and a sense of agency. Whereas best management practices are often very top-down, And people can never, the practices themselves can't catch up with the learning that's happening. If you have a list of best management practices that have all been examined, it doesn't allow for that innovation. So why should we care about the health of the soil sponge? Kat went through a lot of this, so I'll go through quickly, but road just behind my house after that July 1st storm looked like this. Now I live in a town of 2,500 people, most of whom aren't taxpayers. And you can imagine if 75% of the roads of our town were damaged with that big storm, which was true, this is a huge burden on us in terms of the finances. This road is just now being repaired 2 years later. And every time we lose access to a road, we're losing economic issues. We're losing, this was a big place where people came for swimming, so recreational activities, all kinds of benefits that we get from having roads that aren't damaged from storms. But really primarily start thinking about what would it cost to repair this, and what if we were to proactively take that money and hire farmers who are at the tops of the hills to grow a sponge to soak up that water before it goes racing through the culverts, before those culverts get clogged up, and before everything overflows and takes the road away. Another photo from Irene, similar story. And here's an example of kind of a side-by-side, a little bit like that rainfall simulator. This is a photo taken in Saskatchewan in 2014 by Blaine Jerdis, one of the holistic land managers we know up there. And these were farms near his house during a major flood. And these are cropping fields where they're not using the soil health principles. And this is his land just right down the road where all of that rain soaked in just fine. We know about Lake Champlain, algae blooms, which of course then creates issues in the ocean itself, air quality issues, dust, this is the Dust Bowl, but the Dust Bowl is actually still continuing. And cooling is a really key piece here that isn't talked so much about, but if you look at this as same soil, same day, the soil temperature on the left is 87 degrees, and on the right, with fewer soil health principles being put into effect, we have 107 degrees. If we start to put that cooling out and think about regional cooling, which we've seen a lot of work where they find that when there's more photosynthesis happening, when soils are healthier and there's a deeper soil sponge to help those plants be continually transpiring. This is now, we're shifting into Celsius here, but green transpiring landscapes typically cooler than bare soil by 2.3 degrees Celsius and 11.7 degrees Celsius cooler than pavement. So, but you have to have that sponge if you want to have that cooling. Could we put that out into a global model? Well, there's not everybody agrees with this in practice, but in theory, as little as a 5% increase in transpiration on land, which could be through leaf area, acreage, or length of green, could be enough to quickly and effectively cool the planet the amount that it's already warmed. And environmental biophysicist John Norman, who works with Abe Collins at Landstream, looked at these numbers and looked at the theory and said, yeah, he thought that actually worked with his calculations as well. And he said, if we just think about agricultural land, a 23% increase, because agricultural land is only a fraction of the whole, could offset the increase we've already had over the past 70 years. So this is a really intriguing thing, and this is only looking at latent heat fluxes. So there are actually 8 or 9 other processes through which this cooling could happen that all build on each other. So in fact, it might be actually a smaller number than that 23%. Fire protection, the soil sponge means that for one thing, when dead wood falls on the ground, it's going to decompose quickly because there's a lot more fungal activity in there that can decompose it. So there's a lot less fuel load, but there's also just that soil moisture and that cooling that's taking place there. This is a brief, tiny little video shot on a phone by Linda Gibbs's son out in California, during sort of the end point of one of the fires out there last year, I believe it was, and their garden survived a fire that was going on. You can see the neighbors here, and but their garden where they had been building a sponge, speaks the language there, but that's the difference. We look at, you can see the hills have been burning. The neighbor's land, you can still see the smoke happening. So, so Kat showed this list already. I would actually add some more outcomes here, because one of the things that we see is increase in the nutrient density of foods and increase in the cell structure of the plants, which provides protection against insect predation, against viruses, against bacterial infections. And then we're also getting that kind of integrity into the food stream. So not only are the crops protected, but that passes along through the whole food web. So our own health, our own resilience against those kinds of diseases is increased as well. So the narrative that I proposed, this is kind of developed somewhat through this chapter that I wrote for the Soil Carbon Technical Manual for the UN, that healthy soil is like a sponge that absorbs, stores, and filters water and maintains its structural integrity when wet. The soil sponge or soil carbon sponge is essential infrastructure that makes life on land possible. This infrastructure is biological capital, a foundation for all successful human economies and societies. Humans cannot build the soil sponge. It requires a biological workforce. There are principles to keep it and its workers healthy. And our health and well-being is intrinsically linked to the health of these biological workers. Why do we need a new narrative? Well, we can invite people in, like the whole society, into thinking in systems about connections between land use, local economies, environmental health, public health, and human decisions. It's a whole different way of approaching problems. We can bring together diverse political groups towards a common aim. I'll talk more about that in a moment. When we start thinking about rebuilding the sponge, that is not a left or a right issue. Which also then provides a protection against change in politics, because if we have something that's more of a partisan issue, you know, the head of the EPA changes or the head of the agricultural sector changes, and suddenly those rules change. But maybe most importantly is that this soil sponge narrative, or this regenerating healthy functional landscapes, or rebuilding the infrastructure that supports life on land, is a lot more fun than the current climate narrative. I've found that it's starting to shift, but most of what we've been told is to stop doing things in order to save the climate, that we've been bad and wrong, that to buy different things, so to buy new light bulbs, to buy better cars, to buy solar panels, or to fight against the groups that are to be blamed for this. And none of those really are getting at our essential human nature, which I believe is a much more collaborative, creative, and interesting parts of ourselves than those ones that are really getting at our our lizard brain. So, right, to hoard things, buy things, stop and kind of play dead or fight. That's a different part of ourselves, a different part of our brains than the more creative part that wants to work together with other people and with other species towards that common aim. So just a couple more. Are we running out of time?
Yeah, run out of time, yeah.
Okay. So just to say real quickly, consensus building with this kind of shared narrative, we can have unanimous bipartisan votes. And the last questions I'll ask is, what should we measure if we're thinking about this? The amount of carbon in the soil, the amount of phosphorus that's added or run off, or should we measure the structure and function of the living matrix itself? And what should we pay for? Should we pay for each ecosystem service separately, or should we hire people to regrow the natural infrastructure as a whole? Okay, that's where you can download that manual that has a lot of that in there. And I will stop the share here.
Edie, thank you. That's great. So as we begin to wrap up today, questions for Didi about soil health, soil capital, soil as sponge, and then kind of some thinking then that relates to linking that to the payment for ecosystem services approach. Just kind of check see if we have any questions as we wrap up. Nancy, I get a question? And you're unmuted.
Okay, yeah, Didi, thank you very much. I really appreciate that. And you kind of ended with, I think, the big questions for us to think about on the work group is, you know, if the goal is to kind of support these overarching soil health principles to sort of, you know, invest in rebuilding the natural capital that is so essential, like what is a starting place given just the reality of our current situation in Vermont, you know, politically and otherwise, and the extreme kind of public and kind of political focus on water quality. And I mean, that's what I'm kind of wrestling with, because this all makes perfect sense. And yet if we have to, by EPA and just even the public, move the needle on phosphorus and nitrogen, like, how can we move all this forward together?
Well, I mean, I hope it was clear that by moving a little bit back in the chain and thinking about the infrastructure as a whole, that we can address those phosphorus and nitrogen type issues as along with everything else.
Yeah.
I do think that from what I've seen in my work over the last 6 years or so, that having a narrative and a kind of an image, that bread and flour that's now being used all over the world as a kind of a teaching tool, having some really simple images that people can help people start thinking in systems makes the next step much easier. So we've got people, I think, because of the work that a lot of us in the room have done, we now have people starting to be able to think in systems and ask that question of, how do we just simply rebuild the sponge? And I think that the soil health team at the NRCS has done a great job of framing it in terms of soil health, which implies both structure and functional integrity as well. So, and both of those initiatives, the sort of soil sponge initiative that a bunch of us have been working on, and the soil health initiative, seems like those are doing more to change land management than like things about, you know, can we pay for soil carbon gains? Is there a carbon market? Or can we punish people or incentivize people to stop doing this or that? So yeah, I mean, like Kat, I do think that that infiltration is one of the best measures for both structure and function. And it can be done on a kind of a citizen science level with simple water infiltration rings, or it can be done on a more accurate measure with a dual head infiltrometer. But getting people to even notice that, most people, once they understand that, they just want to know, how can I do this? Because farmers, everyone will see this is going to benefit me and everything that's around me.
And it sounds like one thing that might be interesting is if we get a chance to get Heather Darby to present on the Cornell Soil Health Index, one is to see how much that meets and follows the principles both of you have talked about. So that's the first question. And then the second question, how that tool could potentially use to translate into ecosystem services both in terms of soil health or capital broadly, and then specifically potentially to the phosphorus nitrogen question, at least as part of it. So I think those are, Nancy, fair questions we'll have to continue to look at and see how we kind of pull all these things together into a direction. As folks said, the nice part about soil health or capital is it provides multiple ecosystem functions. So if that's the focus, it might do many things, and you have to, of course, figure out what that's worth, quote unquote, what the baseline is. And it also kind of reframes the issue maybe in a different and better way for everybody.
I know that Abe Collins has invited people to go monitor with him, and he's simply looking at 4 measures that he thinks give a pretty good picture of that structural and functional integrity. And yeah, with the Soil Carbon Coalition, we will often look at soil carbon, bulk density, aggregate stability, and water infiltration. That's another set. So there are a variety of sets out there that if you put them together as a whole, you can get a pretty good picture of whether that soil is gaining over time or losing.
That's great. I'm more of the time, so I do want to, this will be recorded and available, and Brian will figure out how to get you the actual file just at the beginning of next week after the holiday. Thank you both, Kat and Dee Dee, for presenting. Really appreciate it. Really interesting and really solid information as we think about soil health, capital, and PES. So unless I see any other questions, which I don't, thank you all. Have a good long weekend. Don't forget our next meeting is on the 21st. Likely the same location as before, but we'll verify that soon, 10 to 2, and we'll send a reminder out next week. And if you haven't filled out the survey for those folks on the phone that we sent out to all the members, please fill that out so we can get your input back on the kind of overall questions and help drive our meeting forward next time. So thank you all. Appreciate it. Have a great weekend.
Thanks, Pat.
Thank you.